So you can see this is a domino effect, right? This is a chain reaction. And those, it start with nitrogen oxide and trigger this chain reaction at the presence of sunlight. And the nitrogen oxide and the free radical further forms NO3 plus other organic molecules. So this will go back and circle again, again, and again. And we all know free radicals are very harmful to human tissues and human organs. And most people believe the cancer start with those free radicals. I will go back to this slide so you will not feel too overwhelmed. And those organic free radicals, they exist, they are present in our body. And if we do not repair, we do not neutralize or quench those free radicals in our body, they will react with our bones, our tissues, with fat tissues, and cause cancer. And normally we have a bunch of free radicals in our body, and we eat healthy, we transform those free radicals. So you probably see this very scary, and some people will be like, wow, how can I remember this? I don't want you to remember this, but I want to walk you through this. So primary automobiles release those compounds, and those very reactive components react with each other, right? At the presence of sunlight that produce the PAN and ozone and aldehydes. Those are the chemical smog. This is all I want you to know, so don't panic. But I want to show you this slide to let you know they react with each other. So this is a cooking reaction. And this graph will further demonstrate why sunshine is so important in the photochemical smog reaction. If you see morning, those chemicals kind of low before sunrise, and after sun rises, it soon will reach the peak, right? And think about the time here, guys. This is morning, after early morning, right? The rush hour, everybody drive to their work. And then it has a little bit, it's a little bit lag, right? Because it needs those components in the air, the cooking ingredients in the air first. And then it's more and more, and the sunshine triggers this accelerated reaction. So this line is VOC, this is aldehyde, this is ozone, and this is nitrogen dioxide, this is nitrogen oxide. And look at here, evening. About noontime, some reach the peak because the temperature is high, right? And with sunshine. What about evening? Why evening there's not another peak? This is also rush hour. Guys, think about it. Why there's no peak in the evening? First of all, temperature dropped, right? But that is not the main reason. The main reason is the sunshine, right? After the sun sets, there's no driven force of this cooking reaction anymore. That's why there's no second peak. This is very important. I want you to understand why this figure look like this. That help you to understand the photochemical smog reaction. Another thing I want to mention about the smog is the unique climate and the geographic features of a city, a land, or a country greatly affect how those pollutants created linger around and go away. So the warm air, the thermal inversions is these two pictures here, okay? So the first picture, that's a normal condition. What is a normal condition when the air gets warmed up and they go up and cool down and come back? So that sort of diffuse contaminants in the air. When some abnormal conditions exist, such as this one, it sits in the valley, right? The city sits in the valley. And at night, all the cold air sink to the surface and the warm air squeeze out to the top. This is like a lid, okay? So because it's reversed, so it's called inversion. So the cold air sits here and the warm air is up above. It's kind of reversed to this motion on the first graph, in the first picture. So the cold air cannot move upward and the warm air cannot sink down. So that greatly prolonged the period of those pollutants sitting on the surface. Another scenario is this city by the ocean. At night, the cool, dense air flows in from the ocean and creeping in through here. And so the warm air was squeezed upwards. Again, this is inversed motion, inversed status, right? The warm air on the top, cold air, the cold air cannot rise up, the warm air cannot go down like this. So that's called the thermal inversion. And that will greatly prolong the lingering of those smog sitting on the surface of Earth. And that will worsen the contamination a lot. Now, I want to talk about acid deposition. So acid deposition is the accumulation of potential acid-forming particles on the surface. And the acid rain, that we heard a lot. And when the dry particles are deposited, an acid does not actually form until those materials mix with water. So a lot of people have this common idea in their mind, acid rain. So only raining acids is called acid rain. But actually that is not the scientific definition. The scientific definition is all of these sources of acid-forming particles, they are referred as acid rain. So no matter it's wet or dry, even the dry particles, if they mix water form acid, that it's also called acid rain. So acid rain is not only rain, it's a deposition of all the particles, all the contaminants. Sometimes dry particles like PM, particulate matters, if they fall to the ground, that is also acid rain. Although they will only form acid after raining, right, when it's mixed with water. But keep this in your mind. The acid rain is all the sources of acid-forming particles, no matter wet or dry. And the causes, we have some natural causes of the acid rain, vegetation, breathing out carbon dioxide, right? And volcanoes, lightning. And I want to point out human activities such as the burning of coal and the use of internal combustion engines. That's a main source of acid rain. So it is a worldwide problem. 1, driving the car. 2, burning the fossil fuel. And the factors contribute to acid rain, that could be the wind, the direction of how the wind blows, right? Geographic features, is that a water body, is that a mountain, that's a flat area, is that a dry deposition, so the composition of the particles is also important. Is that a dry deposition or that's a wet deposition like snow or rain or fog? And this is the direction of wind flow, and acid rain pass hundreds of kilometers. So those acid rain can travel a long distance, and also it goes with the direction of the wind. Oh, this is a very similarly scary feature, picture we just showed you, right? And you can, the point I have here is all those reactions contributing to photochemical smog also contribute to acid deposition. That's all I need you to know. So don't feel overwhelmed. I only have one point. This chemical reaction also contribute to forming of acid rain. So to now you will know burning of fossil fuel and driving vehicles is really bad for the atmosphere. So what acid rain can do to the ecosystem?